Imagination is more important than knowledge. Life is like riding a bicycle to keep your balance. You must keep moving. The only source of knowledge is experience. Strive not to be a success, but rather to be of value. Logic will get you from a to be. Imagination will take you everywhere. The only thing that interferes with my learning is my education. Learn from yesterday, live for today, hope for tomorrow. The important thing is not to stop questioning. Anyone who has never made a mistake has never tried anything new. Peace cannot be kept by force. It can only be achieved by understanding. The measure of intelligence is the ability to change. Two things are infinite, the universe and human stupidity. And I'm not sure about the universe. The only reason for time, so that everything doesn't happen at once. The important thing is not to stop questioning. Curiosity has its own reason for existing. Education is what remains after one has forgotten what one has learned in school. Life is like riding a bicycle to keep your balance. You must keep moving. A person who never made a mistake never tried anything new. Strive not to be a success, but rather to be of value. Logic will get you from a to be. Imagination will take you everywhere. I have no special talents. I am only passionately curious. The only real valuable thing is intuition. We cannot solve our problems with the same thinking we used when we created them. In the middle of difficulty lies opportunity. Life is like playing a violin solo in public and learning the instrument as one goes on. The true sign of intelligence is not knowledge but imagination. A person who never made a mistake never tried anything new. Great spirits have always encountered violent opposition. From mediocre minds, peace cannot be kept by force. It can only be achieved by understanding. Not everything that can be counted counts, and not everything that counts can be counted. Einstein's physics postulates a special relativity. Principle of relativity. The laws of physics are the same for all observers in inertial frames of reference, frames moving at constant velocity relative to each other. Invariance of the speed of light. The speed of light in a vacuum is constant for all observers, regardless of the motion of the light source or the observer. Time dilation. Time is not absolute. It is relative and depends on the observer's motion. Moving clocks appear to tick more slowly relative to a stationary observer. Length contraction. Objects in motion contract along the direction of motion and measured by a stationary observer. Simultaneity. Events that are simultaneous for one observer may not be simultaneous for another observer in relative motion. Mass energy equivalence equals mc, introduced a famous equation that states the equivalence of mass meter and energy, revealing the enormous energy contained in even a small amount of mass. Relativistic momentum and energy. Momentum and energy of an object depend on its velocity relative to the observer and follow relativistic formulas. Relativity of simultaneity. Events that are simultaneous for one observer may not be simultaneous for another observer. In relative motion, causality and spacetime merge space and time into a unified four-dimensional spacetime, where events are described by coordinates in space and time. Twin paradox. If one twin travels at a high speed in space and returns, they would be younger than the twin who stayed on Earth, illustrating time dilation. Experimental confirmations. Numerous experiments, such as the Michelson-Morley experiment and particle accelerators, have confirmed predictions of special relativity. Equivalence principle. The effects of gravity are equivalent to the effects of acceleration in a freely falling elevator. There is no gravitational force acting on objects in psi. Curvature of space-time. Massive objects, like planets and stars, warp the fabric of space-time around them. This curvature is what we perceive as gravity. Geodesics. Objects in free fall follow curved paths in space-time called geodesics. These paths are the natural trajectories that objects take under the influence of gravity. Gravitational time dilation. Clocks in a strong gravitational field run slower than those in a weaker field. This effect has been experimentally confirmed, such as with atomic clocks on high-speed airplanes or in strong gravitational fields. Bending of light. Gravity causes light to follow a curved path as it passes through a gravitational field, as demonstrated by the bending of starlight near massive objects. Gravitational redshift. Light emitted from an object in a strong gravitational field is shifted to longer wavelengths, or redshifted due to the influence of gravity. Frame dragging. Massive rotating objects, like the Earth, drag space-time around them as they rotate, a phenomenon known as frame dragging. Cosmological constant. Originally introduced by Einstein as a fudge factor to allow for a static universe, later abandoned when observational evidence pointed to an expanding universe. Einstein's field equations, a set of equations that describe the fundamental interaction of gravitation as a result of space-time being curved by mass and energy. Black holes. Solutions to Einstein's equations predict the existence of black holes regions of space-time, where gravity is so strong that nothing, not even light, can escape. Photoelectric effect. The photoelectric effect is the phenomenon where light shining on a material surface ejects electrons from that surface. Wave-particle duality. Einstein's work challenged the prevailing wave theory of light and introduced the idea of the dual nature of light, both particle-like and wave-like. Energy of photons. The energy of a photon is directly proportional to its frequency nu, according to the equation E = h, where h is Planck's constant.